Hey friends, we're going to walk through the ambiguous case of solving a triangle. That's anytime we have SSA. All the steps I'm about to show you are just for that ambiguous case of SSA, only for this acronym that was never used to prove triangles congruent. That's when you do these steps we have to do. And in this situation, the reason why this wasn't a way to prove triangles congruent is because this doesn't always form a unique triangle. There could be a couple different triangles that have this specific case. There could be none at all. And here's how we tell. We look at our triangle, we see that we have a given angle, a given side, and a given side. So it's side-side angle. And we want to look at the height. Now, of course, the height, we all can draw that in here really quickly. We do form that right triangle, and if I want to figure out the height of this, I want to focus on the right triangle that I just created. So we can see, if I kind of focus my energy there, I want this vertical component of this right triangle with this angle over here. So I would know that the height would equal 31 times the sine of 20.5. That's how I can figure out this vertical component by using the sine of this angle times this hypotenuse over here. And doing a quick calculation on that, we can see the answer ends up being 10.86. Now here's why the height becomes so important for figuring out how many triangles we have. Let's just think this through for a minute. There's three things that could happen. Either there's no triangles that do this, or there's just one, or there are two. And the way we can figure this out is by comparing these sides together along with this height. And I'll write these down as a set of rules, but I want you to think for a minute about how this is supposed to work. It turns out that if this side is bigger than the other given side, like if this happened to have been more than 31, then I would know there was only one triangle that could work, and I wouldn't actually even need to check this height at all. If this height is shorter than this length here, then there'll be two cases, because we'll have the case that I currently drew, and we can have this length swing over to the other side and make that second triangle that looks like this. And if this height is more than this side over here, then if you look at that guy's video, he'll explain you can't get a triangle at all. Because if this height happens to be longer than this side will never touch the other side. So in this situation, because this height is less than this side, and this side is less than the other side, I know there'll be two cases. Now that I've established that, really the hard part is just organizing the work. And I'm going to just draw case 1 and case 2 and try to be as neat as I can. So for case 1, let's just say we've got the picture that I already drew. And the picture is kind of irrelevant. It's 12, it's 31, it's 20.5. This guy's B, this guy is A, and this guy is C. So I think at this point, you guys, if the other notes made sense, you can probably solve all this without too much help from me. So I would suggest you pause the video, and I'm going to pause and write my calculations down for each step and just quickly talk through them to make the video a little bit shorter. And I'll do it step by step. So I'm going to start this off actually by solving for the only thing that I can solve for. See if you can figure that out without my help. And if you need a hint, pause the video, try and figure it out. If you need a hint, when you unpause, I'll be saying what you can solve for first. So based off these givens, since I know this side, and this side, and this angle, I can find this angle. I'm going to set up the calculations for that and do that. So because I was solving for an angle, I used a version of law of sines where the angles were on top, just so I didn't confuse myself. And I said sine of b over 31, sine of this over 31 equals sine of 20.5 over 12. That's my little proportion here. And if I want to get the sine of b by itself, multiply both sides by 31. So the sine of b is going to equal 31 times the sine of 20.5 all over 12. Quick calculation gives me this. And now, quick reminder to solve this guy. We know the sine of b equals this ratio. So if I go a little further, I can say b equals the arcsine of 0.904, and that's a simple calculation on the old calculator. And I got 64.783. I do want you guys to get in the habit of going to 3 decimal places. And if you didn't get that number, make sure you're in degree mode. We're dealing with triangles and degrees, so that's what should happen. And now I'm good to figure out the next thing. What's the next thing I can figure out? I just got that this guy is 64.783. Pretend that says 64.783. What's the next thing I can figure out? Pause and think. When you think you know, unpause. I can find angle C by using the fact that the angles add up to 180, and then once I know angle C, I can use law of sines one more time to find the side opposite of angle C. I'm going to do both those steps in one fell swoop. Feel free to pause and do it ahead of me. So to finish off this case, I know that angle C equals 180 minus the sum of the other two angles. I got 94.717 degrees, and I labeled that as angle C and boxed it so that when Mr. Dempsey's grading my stuff, he's not freaking out trying to find everything. And then for this part, I will say you could have set up a slightly different ratio. Maybe instead of using 12, we're using law of sines again. We have angle C, so we can find the side across from angle C. I'm using the version of law of sines that puts the side on top because I'm trying to find the side. I always like my unknown in the numerator. It's just less stressful. So I have to have C over sine of 94.717. You maybe could have used 31 over the sine of 64.783. That's fine. I'm always going to err on the side of using given information. So I used the 12 and the 20.5, multiplied that through. To get the C by itself, I had to multiply by this. And then a quick calculation on the old calculator tells me side C is 31.149 meters or feet or whatever. And all of that is case 1. Great. Case 2 is going to be very similar. Here's the situation. The whole reason why this has two cases is because the height of this triangle was less than this other side, but this side was in fact less than the side over here. That means there's, like, if you imagine a hinge here, this could swing over and land here. This could be 12. So our triangle could look like this. This is my case 2, where this is 31, this is 20.5, and now I got to figure out what becomes of, oh, this is 12. So I'm sorry, how am I going to find this angle? Well, the truth is we already did most of the work, because the moment I figured out what this angle was, 64.783, up here in green, this triangle that we have up here is in fact an isosceles triangle, right? Both these sides are 12, which means if this is 64.783, so is this. And if this is 64.783, this is the supplement of that angle. So without doing too much more work, I can find for case 2, I can take the work I did right off the bat over here, and I can just find this guy's supplement. In case 2, angle B is going to equal the supplement of this, which we'll find by going 180 minus 64.783. And that'll tell us this angle right here. And I'm going to pause and knock the rest of this problem out. I'm going to find all the missing pieces. So when you unpause, you're going to see all my work there. So you might want to pause and just see, how you did yourself. So here's my final work. I figured out the supplement of angle B. That's pretty straightforward. I like to label my triangle as I go because it always kind of directs me on what to do next. So once I label that 115, 217, I'm like, oh, what can I find next? I can find this angle pretty easily by knowing these three things add up to make 180. So I took, of course, 180 minus the sum of these angles to find that angle C would have to be 44.283. So once I knew what that guy was, this is all that was left. And I'm going to use law of sines, and I'm going to use the version with the side on top. So I said C over the sine of this angle I just found equals, and again I'm going to err on the side of using given information, 12 divided by sine of 20.5 to get this final answer. So when it's all said and done, I know it looks like a lot of work, and that's just because it is. It's a ton of work. And it's really going to have to, you're going to really have to use your knowledge of triangles that you already have to do this smoothly. But I hope it's not too bad. And just, if you have questions, let me know. We'll do some more practice. Tons of fun.